Chapter 11, Areas of Polygons. Today we're going to cover section 11.4, Areas of Regular Polygons. Our objectives will be to know and use the formula for the areas of regular polygons. How could you find the area of the following shapes? And the following shapes drawn are regular polygons. And to be a regular polygon, it has to have congruent sides and all the angles are also going to be congruent. Well, if I start to look at these shapes, I already know the area for a triangle is 1/2 base times height. I know a square, the area is just a side squared. And then I get into shapes that aren't either of those, and they don't fit rectangles or parallelograms or any of those. So how can I try to come up with one formula that's going to get all the regular polygons? And the one thing I tend to notice for these is this. If I find sort of the center of the regular polygon and connect each vertex to it, I get a bunch of triangles that are all the same size. So if I locate the center, I end up getting, again, a bunch of triangles that are all equal in size. So if I can find the area of one of these triangles, I can just multiply by how many triangles I get and pretty much figure out all of them. So the formula for this is going to come from the fact that I can find the area of one of these triangles and then turn that into the area of the entire shape. Okay. So theorem 11.6, the area of a regular polygon is equal to half the product of the apothem and the perimeter. And here's the reason for this. If I come back to these, and I'm going to just pick the top right shape here, if I wanted to find the area of the entire pentagon, I could just take the area of one of these triangles and multiply it by 5. But the formula said that the area was 1/2 the apothem times the perimeter. Well, here's what these things actually mean. The apothem is just this height, so it's the distance going from the center to the side. So I would use that in finding the area of my triangle anyways. Where things get a little different is, instead of finding just the base here, if I use all the bases going all the way around the shape, I'm going to get all the triangles at once. So instead of just using the base, in the formula we're going to use the perimeter, which gets me all of the bases for all the different triangles. And the apothem is really just the height of one of these triangles. So our formula is really just 1/2 base times height, but we're using apothem, which is telling me that it's the height inside of this regular polygon. And we're using perimeter because the perimeter gets us all of the triangles at one time instead of just one. So it says, complete the table for the regular triangle. And I can see off to the side where it has S is the side of a triangle, A is an apothem, R stands for the radius, which would be, imagine if you inscribe this triangle inside of a circle. The radius is the distance from the center to any vertex. And then down at the bottom here, I can see that this 1/2 S is just telling me it's half of the entire side. So completing the table. All right, let's see. I know that if this is an equilateral triangle, because it's regular, that this would have been a 60-degree angle over here, which in the triangle it got cut in half, so this is a 30-degree angle. So I do have a 30, 60, 90 triangle over here. So if I go to fill out this chart, if the radius was 20, so if I came over here and told you that this radius was 20, the apothem then is half of that, it's 10, so filling that in the chart. Well, if that's 10, then this half of a side would be 10 square roots of 3, which means an entire side would be double that, which would be 20 square roots of 3. Well, if one side of my triangle is 20 square roots of 3, and the triangle has 3 sides, the perimeter would be 3 times as big as that, which would be 60 square roots of 3. When I come to fill in the area column over here, based on my formula, I think I'm just taking 1/2 times whatever's in the apothem column times what's in the perimeter column. So if I start to write down what this would be, I know that it's going to be 1/2 times the apothem, which was 10, times the perimeter, which was 60 square roots of 3. Well, let's see, multiplying. Half of 10 is 5. 5 times 60 is 300. And then I still have the square root of 3. Coming back over to my triangle for a new problem. I still know that it's a 30, 60, 90 triangle, but now the side is going to change. So let's see what happens. So in this problem, they're telling me that the apothem is 4. Well, I know if that's 4, if I came to this radius over here, it's twice as big, it's 8. If I come down to this bottom side, it gets bigger by the square root of 3, so half of a side is 4 square roots of 3. If half a side is 4 square roots of 3, the entire side is going to be 8 square roots of 3. Multiply that by 3, and you get the entire perimeter, which is 24 square roots of 3. And now I go right to the formula. So the formula is 1/2. Apothem, for in this case, was a 4. The perimeter was 24 square roots of 3. And now let's multiply. Half of 4 is 2. 2 times 24 is 48. And I still have the square root of 3. Let's try a different missing piece. In this problem, we're going to have that the side is 6. Well, if an entire side is 6, half of a side is 3. And if half a side is 3, and I want to go to what the apothem is, I need to divide by the square root of 3. So what's 3 divided by the square root of 3? Well, I can't leave it like that, so I fix the square root of 3 part. And I end up getting 3 square roots of 3 over 3, which reduces to just square root of 3. So my apothem is a square root of 3. Well, if I go from my apothem to the radius, it doubles. So that would be 2 square roots of 3. And if I look over at my chart, if one side was 6, the perimeter is 3 times as big as that, which is 18. Now I go to my formula, 1/2 times the apothem, which is a square root of a 3, times the perimeter, which is an 18. Well, then if I multiply, half of 18 is 9, and then I still have the square root of 3. The next problem, and it might seem like we're doing a fair amount of these, but each one is doing it as if we were missing a different piece, so they're all just a little bit different. So our last one here, if I go through, we have the perimeter, and I know if you give me the entire perimeter and I just want one side, divide by 3 because we have a 3-sided shape, so I get 12 square roots of 3. Well, if the whole side is 12 square roots of 3, half of a side is 6 square roots of a 3. Then if I go from there to the apothem, I need to divide by the square root of 3. 6 square roots of 3 divided by the square root of 3 leaves me with 6. And the radius is double that, which is 12. And now to my formula. So area is 1/2 times the apothem, which is 6, times the perimeter, which is 36 square roots of 3. And now I multiply. Half of 6 is 3. 3 times 36. And you get 108. And we still have the square root of 3. Doing the same thing for a square now. So let's see what happens if we go through and fill in the information for the square. And you can look again, it may seem like we're doing a lot of problems, but I'm just trying to show you an example of what happens if you're missing a different piece all the way along. So the radius in this problem is 8 square roots of 2. Well, how do I get these other shapes? Well, I know if this was a square, there are 90-degree angles, and if I split that in half, I'm really getting a 45-degree angle out here. So I really have a 45, 45, 90 triangle. So as I go through this problem, when I go from the radius to the apothem, I'm dividing by the square root of 2, which means that this apothem is just an 8. Well, since it's an isosceles triangle, I know that down here, this half of a side is 8. If half of a side is 8, the entire side is 16. And this chart doesn't have a perimeter column in it. So when I go to my formula over here, and I think that the area is 1/2 times the apothem times the perimeter, I have to think of what the perimeter is on my own. So I get 1/2 times the apothem, which was 8, times what's the perimeter going to be? Well, the perimeter is going to be 4 times one of the sides. So 4 times 16 gives me a perimeter of 64. And now if I multiply this out, half of 8 is 4, and I need to take 64 times 4, which is 256. And we'll get our new information over here. So what if for the next problem, we have that the apothem is a 4. So if the apothem is 4, I know that the radius gets bigger by the square root of 2, so it's 4 square roots of 2. I know that the apothem is the same as half of a side. And if half of a side is 4, an entire side would be 8. And I'm going to go to my formula. So formula says 1/2 times the apothem, which is a 4, times the perimeter. Well, if one side is 8, all 4 sides should be 32. And now half of 4 is 2. 2 times 32 gives me 64. Going to a new problem where they're giving me a different missing piece. So let's see. In this one, if they tell me that a side is 6, well, if an entire side is 6, half of a side is 3, I know that the apothem and this half side are the same because it's an isosceles triangle. So the apothem is 3. If I go from a side to the hypotenuse in a 45, 45, 90 triangle, it gets bigger by the square root of 2. So the radius is 3 square roots of 2. And now I go right to my formula. My formula says take 1/2 times the apothem, which is a 3, times the perimeter. If one side is 6, all 4 sides should be 24. And I'm going to multiply. So I'm going to now take half of 24 is 12. 12 times the 3 gives me 36. The last one, they're giving me the area and asking me to figure out all the other pieces. Well, let's see. Here's where I might actually do this problem in reverse a little bit and not necessarily use the whole formula for some of this. If I know that the area is 100, well, I also know that the area for a square, I could just say that the area is a side squared. So what number squared is going to give me 100 could tell me that the side is 10. And if one of the sides is 10, half of a side is 5. Well, the side and the apothem are going to be the same. So the apothem is a 5. And then when I go from the apothem to the radius, it gets bigger by the square root of 2. And my final answer is 5 square roots of 2. Now, if you look at the chart, you might have noticed something else. And this is where we have different formulas to get areas for things. So if you were going through this chart and you realize that I know a square is a regular polygon, and I can use this formula up here that the area is 1/2 times the apothem times the perimeter. Well, we also had the formula for a square as just being a side squared. So you could have, if you noticed, skipped doing the fact that you're doing 1/2 times apothem times perimeter, and you could have just said a side squared 16 squared is 256. A side 8 squared is 64. A side 6 squared is 36. So we do have multiple ways to get to answers, so you do have some options when you get to some of these shapes. Completing the table for a regular hexagon. All right, let's see what's going to happen for the hexagon. If I look in here, I notice that a hexagon has 6 sides. So how big are the angles? Well, I know a complete circle is 360 degrees. So if I take 360 degrees and I divide it by 6, I get 60. Well, so if I were to imagine drawing all of these big triangles in, that's telling me that each of these angles is a 60. But if I look at this triangle down here at the bottom, I know that the angle up here at the top is also going to be 60, but then I'm cutting it in half for just the one triangle. So I'm really going to get a 30-degree angle up there. So I'm going to use the fact that right up here is a 30-degree angle, and that I have a 30, 60, 90 triangle as I go through and try to find the missing pieces. Okay. Again, I'm going to do a bunch of sample problems on the right, a different problem for each missing piece, so you may skip around and watch what you really need. So let's get started. The radius is 2. Well, if the radius is 2, I normally go to the piece down at the bottom, which is going to be 1. So half a side is 1, which means that the entire side is going to be 2. Well, if that piece is 1 down here at the bottom, and I go to the apothem, it gets bigger by the square root of 3, so it's just 1 square root of 3, or the square root of 3. I have a 6-sided shape, so when I go from the side to the perimeter, all I'm doing is multiplying by 6. So if one side is 2, the perimeter is 12, and going to my formula then for the area, it's 1/2 times the apothem, which is the square root of 3, times the perimeter, which is a 12. Half of 12 is 6, and then you still have a square root of 3. Looking at some new information over here. So next problem, I noticed that they give me that the apothem is a 4. Well, if that's 4, and I come down to this half of a side, I go from 4 and I need to divide by the square root of 3. So that piece is 4 divided by the square root of 3. I'm going to rationalize it right away, which is 4 square roots of 3 over 3, and none of that reduces. So my half a side is 4 square roots of 3 over 3. So my entire side, I need to double that, which would be 8 square roots of 3 over 3. Well, going from there to my radius, I also just double this answer, which is, so my radius is also going to be 8 square roots of 3 over 3. Going to the chart, looking for the perimeter. Well, the perimeter is just a side times 6. So I can imagine if I took this and I wanted to multiply it by 6, what would I get? Well, 3 and 6 are going to reduce, so I'm going to get 2 times 8 square roots of 3, which is 16 square roots of 3. On to the final area. The area is 1/2 times the apothem, 4, times the perimeter, which is 16 square roots of 3. And let's see, half of 4 is 2, 2 times 16 is 32, and then I still have the square root of 3. New problem. Let's see, for this one, they give us that the side is 6. So if an entire side is 6, I know half of my side is 3. If this piece down here is 3, I know my radius is double that, which is 6. I know that if I'm going from the half side to the apothem, it just gets bigger by the square root of 3. So the apothem is 3 square roots of 3. I know now in the chart from side to perimeter, I'm multiplying by 6, which is 36. Doing my final area, it's 1/2 times the apothem, which is 3 square roots of 3, times the perimeter, which is 36. And when I multiply this all out, I'm going to do half of 36 first, so half of 36 is 18. 18 times 3 is 54, and then I still have the square root of 3. Last one. They're giving me the perimeter is 36 square roots of 3. Well, and I know if I just go backwards from the perimeter to the side, I would divide by 6 and get 6 square roots of 3. If an entire side is 6 square roots of 3, then over here in my diagram, half of a side is 3 square roots of 3. Now going from half a side to the radius, it gets doubled, so the radius is 6 square roots of 3. And if I go from half of a side to the apothem, I need to multiply by the square root of a 3. So 3 square roots of 3 times a square root of 3. Well, square root of 3 times square root of 3 is really just a 3. So I end up with 3 times 3, which is a 9. And final area then. 1/2 times the apothem, which is a 9, times the perimeter, which is 36 square roots of 3. Half of 36 is 18. 18 times 9, let's see what that is 162. So we get 162 square roots of 3.